So for proofs or verify, the main rule is that you can only work on one side. So to sort of emphasize that, a lot of times we'll draw a line down from the equal sign, because this is not an equation like normal where you might think, well, let me multiply both sides by 3 and now I'll at least clear the 3's. You're like, well, you're right, but you're not allowed to do that. You can only work on one side. So you can look at the other side. So my goal is to get it to be 1/3, but I can't do anything. I mean, I'm going to work on the left side of this. My only goal is, or my only thing I can do is work on the left to make it look like the right. So don't multiply both sides by sine or 3 or tangent. Don't think, well, I'll multiply both sides by 3 tangent sine. That way I'll get rid of a denominator. Like, you can't. You can only work on one side. Usually you want to pick the more complicated side to work on, just because it's a whole lot easier to simplify down than to sort of expand up. Now, legally, technically, you can work on either side, but it would be really tricky to start with 1/3 and turn it into all of that. Like, you'd have to get real creative to make that happen. So almost always you start on the more complicated side and hope that things reduce in your favor. All right, so the only way to do these or learn them is to do them. So we're just going to work some of these together. So again, no notes today other than working some of these together. So number 7, secant minus cosine over 3 tangent x sine of x. All right, I don't see any trig identity, or I don't see any Pythagorean identities right away because nothing's squared. Tangent is sine over cosine. I don't know that would help. Secant is 1 over cosine. There's not a lot of good options here, and when that happens, your best bet is to just write everything in terms of sine and cosine and see what happens. So 1 over cosine minus cosine over 3 times sine over cosine times sine. All right, I've got an idea now. Both top and bottom have a denominator of cosine. So I'm going to multiply the top and the bottom by cosine. That way it'll clear that denominator out. All right, I can't multiply both sides of the equation by cosine, but I can multiply top and bottom of a fraction by cosine. So on this first term, the cosines cancel. On the second term, I get cosine squared. But that's okay. That might mean a Pythagorean identity is coming. In the bottom, it's not add or subtract, so that cosine is going to cancel with the cosine, and that'll be all I have to worry about. That leaves me with 3 sine squared of x. Right? Because you're not going to distribute across multiplication. You distribute across addition or subtraction. Okay, now we're getting close, because 1 minus cosine squared. Again, it's hard for me to think of the identity and manipulate it like all in my head at once. So I'll usually write the identity down, and then I can manipulate it and use it. So looking at the identity, what does 1 minus cosine squared equal? If I move things around, sine squared. So I can replace, which peeking ahead is really good because I'm trying to get to 1/3. 1 minus cosine squared is sine squared, and then I'm almost there. So you're not done until they match exactly, even though you're like, it's right there and I'm out of room. You got to make it get all the way down there. And again, if you want to sound fancy, you put a QED on there that says, I did it. Take your victory lap. Let's do number 9. I Again, another one. All of these are real easy to see which side you should work on. If they're sort of equally complicated, then it's a little harder to figure out which side you should work on. You can always work on either side. It's just you would have to get pretty creative to expand cosine, somehow blow it up to look like all of this. So it's always easier to work on the more complicated side. So thoughts on number 9? I don't see any Pythagorean stuff yet. I don't see anything that'll cancel just yet. So thoughts on number 9? What to do first? This is sort of the fallback thing. If nothing looks like it's going to work, put everything in sine and cosine. So why don't you do that and see how far you can make it with this one. So put everything in sine and cosine and see what happens. So put it in terms of sine and cosine. Write small and zoom in. The sines will cancel. Then I've got sine squared. Actually, I already have a common denominator. So that's kind of nice. Especially since I'm aiming to get one term there. So sine squared minus 1 over cosine. That looks like a Pythagorean identity. Again, I can't think about the identity and manipulate it all at once, all in my head. That's too much for my brain to handle. So I know sine squared plus cosine squared is 1. So that means sine squared minus 1 is equal to negative cosine squared. Also peeking ahead, I got to get a negative from somewhere, and that's where it comes from. Sine squared minus 1 would be negative cosine squared. And then we're pretty much there because one of the cosines will cancel. And we got it. Questions on that one? Toby? This line? So I'm looking at this and I'm thinking, I'm hoping to see like reciprocals that'll cancel maybe, or I'm hoping to see squared things so I can use Pythagorean. I don't see any of that. So what I did was rewrite everything in terms of sines and cosines. That's sort of I don't see anything, so let me just go to sines and cosines. And so I was sort of lucky enough that the sines canceled on this one. Well, let me stop there. So I replaced tangent with sine over cosine. And then over here I replaced tangent with sine over cosine. I replaced cosecant with 1 over sine. So I've got to know all the rules. And once that happened, then things started to kind of fall into place because sines canceled. Then I had a common denominator, so I was able to add the tops or subtract the tops. But you got to know all the rules so that you recognize when things are happening. Looking at number 11, what do you see? What do you think is happening first, or what do you see first on number 11? You could do a distribution, but you're right, it would be a double distribution, so it'd be kind of ugly. What else do you see? I'm hoping you recognize something there. That equals something. I don't know what it is right off the top of my head, but that's if there's something squared, I'm pretty sure that's a Pythagorean identity. Let's see. I think it's tangent squared plus 1 equals secant squared is the identity. So yeah, secant squared minus 1 would be tangent squared. So I'm going to replace secant squared minus 1 with tangent squared. what do you think you do next? Yeah, change everything into sines and cosines. And like you're peeking ahead, your answer is tangent. So if you put everything in terms of sines and cosine, what are you expecting to get on? What are you expecting it to simplify to on the left-hand side? Well, sine over cosine first, because that would be tangent. So make the sine and cosine replacements, and you're hoping you land at sine over cosine, because that would give you tangent. See if you can finish it out from there. So replace everything with sines and cosines. Lots of stuff cancels out. You're left with sine over cosine, which is what we're hoping for. Are you through with this proof yet? No. Like, you're almost there. You're on the doorstep. It's obvious what's next, but you've got to make the left look exactly like the right. So tangent of x equals tangent of x. Yay, you're done. Now, I want to back up for a second, and we talked about trying to kind of game the system yesterday. Like, you know what you're supposed to land at, so how do I fool Mr. Wolf into getting me points without knowing what's going on? So let's say you make it that far. You know you have to get the tangent of x. And so you know, and obviously if you do that, like, that's clearly, I'm not giving you credit for that. Like, I know. But if you can also still kind of work backwards. So if you try to work backward and say, well, I know I'm supposed to land at sine over cosine, like, you got a better chance of fooling me if you put some more work in there. If I'm grading carefully the way I should be grading carefully, you're not. Actually, you would get a point for this because we made it. But I should, if you left that off and you just kind of were trying to think backwards of, I got to get the sine over cosine, so maybe I'll just put sine over cosine and leave out the middle part. You're closer, right? So it's okay. I don't want to say to try to fool me, but it's okay to try to think backwards and maybe try to kind of meet in the middle. And if you don't get there, maybe I don't see it, or maybe I see it, but at least you maybe get more points because of this than if you didn't have that. Again, don't try to fool me, but it's okay to show your work and try to figure it out. All right, so the rest of this worksheet is your assignment. So that's 5 more proofs for you and a couple more multiple choice questions on the front. There's plenty of time left, except that you're going to head to your counselors. I don't know how long that'll take. So go ahead and head off to your. This doesn't need to be on video. Let me stop the video.